A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. In today's lecture, we will discuss the heat conduction, thermal conductivity, and heat convection. Is actually the we also need to discuss the radiation. These are actually the three different type of means by which heat can transfer from one place to another place. So this will be the topic of today, and this topic has been taken from the course outline of thermodynamics. What is our objective from this lesson? We need to understand the concept of heat conduction, how conduction occurs, and what is on which factors the heat conduction depends, and when it will be fast or slow. We need to know all these parameters. We need to know the concept of thermal conductivity. What is the constant thermal conductivity on which the heat conduction depends? So we need to discuss this as well. And at the end, we need to know about heat convection. How heat can be transferred from one place to another place with the help of convection process, and what is the basic idea behind that. The first part of the lecture is devoted to the heat conduction. If we have a material, or maybe a part of that material, or maybe consider a metal slab that has been maintained in such a way so that there is difference of temperature at the two ends of that slab. One end of that material or that metal is at higher temperature, and the other part or other end of that material is at lower temperature. So it's possible there will be definitely a continuous temperature distribution throughout this particular metal or the sample on which we are going to examine the heat conduction process. So one end of this metal is kept at higher temperature with the help of flame or some electric means, so that we can increase its temperature, and other end of the same material is placed at low temperature, with the help of some cooling agents. So we need to calculate the transport of energy between neighboring volumes by virtue of temperature difference. So that is actually the heat out, as there is a temperature difference and both the volumes are actually the parts of the same material. So what happened, there is a temperature difference, so by virtue of temperature difference the heat will move, or heat will transfer from one end of the conductor toward the other end of this conductor, and this process is actually called as a heat conduction. This process is called as a heat conduction, and this is only due to the difference of temperature. If there is no difference of temperature between the ends of the conductor, so there will be no heat flow. So how we can face, if we consider that the difference of temperature between the two ends of this material is one is kept at T and other is kept at T plus T. Keep in mind there should be difference between T and T plus del T. If there is no value for del T, definitely there will be no transfer of heat. This same concept has been maintained for two different materials that are kept at high temperatures, and both that are kept at different temperature, but they are brought in thermal contact with each other. In this case, we only consider a single material whose two different ends are at different temperature, and as a result of the difference of temperature, the heat flow from the end at higher temperature toward the end at lower temperature. This is the simple case. If we consider a bit complicated case, so we can consider two different systems, and both the systems have different temperature. As far as there is temperature difference between the two systems and both the systems are brought in thermal contact with each other, so the heat will flow from the object or from the system at higher temperature toward the object or toward the system at lower temperature, and this heat flow will continue until both the objects or both the system achieve the same temperature. And the other important thing is that the heat flow depends upon the difference of temperature. If there is huge difference of temperature, the heat flow will be high. Later on we will see the same thing in equation. So we are considering that one face of this slab of the metal slab or the material is at temperature T and other is at T plus del T. So what happened? So we consider that for a given time and area, Q is proportional to del T divided by X. This also depends upon the width of that material, provided that del T and del X are small. Del X is actually the distance through which the temperatures, the heat moves. The length of that particular volume element what we are considering, and del T is the difference of temperature. So what happens? Q divided by T per unit time, the heat transfer is proportional to the del T divided by del X, and A is actually the area of that particular material. So if we generalize the same equation, would happen dQ divided by dt is equal to minus Ka dt divided by dx. Here dQ divided by t is the rate of transfer of heat, and dt is the difference of temperature. Is actually dt divided by dx is actually the difference of temperature. A is the area of that particular material or the sample under investigation, and K is the thermal conductivity. That is actually a constant quantity and it depends upon the nature of the material. Keep in mind the thermal conductivity is different for different material, and it is actually a constant depending on the nature and arrangement of atom inside that particular material. Here we can see there is a negative sign in this equation, and this negative sign shows that the heat will flow from a body. This is actually the conventional science describing the heat flow, and conventional science is that a body, the heat will flow from the portion having at higher temperature toward the portion at lower temperature, or in other words we can say that heat will flow from the system at higher temperature toward the system at lower temperature, and this gradient and this heat flow will continue until both the body achieve the same temperatures. So this is actually the, and there is other important phenomena that there is the actually the negatives also show there will be gradual decrease in the heat flow. There will be gradual, if you consider that the object at high temperature is not connected to a heat reservoir, so there will be gradual decrease in heat flow, because as the heat is moving from the object at high temperature toward the object at lower temperature, so the difference will gradually decreases. And we already discussed that when the difference decreases, so the heat flow will also the rate of heat flow will when the difference decreases, the rate of heat flow will also decreases, because it depends upon the heat flow between two objects, depends upon the difference of temperature between that particular object. And we have experience from our daily life. If we touch an object that is at very high temperature, at very short interval of time we can get shocked out of it. But if we touch a body which have a bit higher temperature than our body but not so high, so even if we keep our hand on for a bit longer time, it will not transfer a maximum amount of heat. So it means the most important thing is that the heat flow depends upon the difference of temperature. So the dt divided by dx is actually the temperature gradient which we are mentioning, and K is the thermal conductivity. As we discussed, is depend from material to material. So what is actually the thermal conductivity? Is actually the property of the material that that allow the easiness, that how it can offer the flow of heat. If it has higher value of thermal conductivity, so we can consider such material to be conductor. But if it has low value of thermal conductivity, we can consider such material to be insulator. So it means it is actually the way, or it is actually the value through which it can allow the heat for conduction. So normally we have large value of thermal conductivity for conductor and a small value of thermal conductivity for insulator. So the other thing what we need to discuss is the thermal conductivity and its measurement. This is also the second part of the lecture, where we need to know what is actually thermal conductivity and how we can measure the thermal conductivity of some semiconductor material. So for this purpose we need to perform some experiment, and this experiment is very simple. we need to consider a metal bar, and one end is heated electrically with while the other is placed or it is cooled in with water. So we can consider a metal bar. In this case, one end of this metal bar is heated electrically, and the other end of the same metal is cooled with water. So what happened? The surface of the bar is thermally insulated, and the heat loss through the insulation is calculated from the rate at which heat enters the water from the supplied electrical energy. The rate of heat flow we can easily calculate. How much we can calculate? It's very easy. We can calculate it that the heat enters. We can calculate it from the heat loss through the from the rate at which the heat enters the water from the supplied electrical energy. So we can get this value. So how we can? We can just minus the value from that, the difference that how much heat is created by the electrical instrument and how much heat is transferred from that end toward the other end of the same material, that is actually the conductor. So what happened? We can easily measure the temperature at the two ends of this conductor with the help of thermocouple, and we fix 2 points, one at one side and other side, and both are separated at a distance L, and with the help of thermocouple we can calculate the temperature of it. We can measure the temperature of it. So the thermal conductivity, as we can get the value of thermal conductivity from the last equation. In this equation we have also the value of thermal conductivity here in this case. So we can also get the value of this thermal conductivity, and so after simplifying that equation we can get the value of thermal conductivity, that is equal to K is equal to L divided by A into T1 minus T2 dq divided by dt. So from this equation we can get the thermal conductivity of any material. So for a particular conductor or insulator we can measure its values. If heat is not transferred from one end toward the other end, so we can consider that insulator and we can calculate its thermal conductivity as well. So here when we consider that T1 minus T2 is small, then the value is practically equal to the thermal conductivity at mean temperature. So this is actually the thermal conductivity is the measurement of the this is actually the property of the material to allow the heat transfer by that particular material, and it is measured in watt per m dot k, and that is actually the dimension of the thermal conductivity. So if we can compare the thermal conductivity, the variation in the thermal conductivity with a wide range of temperature for different materials, including some solids, gases and liquids. So what will be their variation? Here on the horizontal axis we have temperature, that is measured in the unit of Kelvin, and on the vertical axis we have thermal conductivity, that is measured in W per m dot k. So what happen? Let's come toward the helium gas. Its thermal conductivity with the increasing temperature is thermal when it is in the gas form. So what happen? Its thermal conductivity starting from 5K or maybe 3K is increasing continuously with increasing temperature, and looking to reaching at 500 K. So we have the same for, if we can consider the glass, or maybe the glass, there is very short variation of thermal conductivity between 5K and 500K. For ice, for water, when it is in iron form or maybe in solid forms, so it has high thermal conductivity, but it's slowly, when it is there is a phase transition and it come into water form and liquid form, so its thermal conductivity is greatly reduced, and further reduction in the thermal conductivity is found when it is converted into steam, gas form. Similarly, we have very small variation in thermal conductivity in stainless steel with increasing temperature. Aluminum alloys, there is a variation in thermal conductivity. Normally for conductors, the normal behavior is that increasing temperatures lead to the increase in thermal conductivity for conductors. But for insulator, the thermal conductivity is with increasing thermal conductivity is increased for conductors. So we have for aluminium there is also increase, a very short change in the thermal conductivity. And some for helium solid we have also a variation, there is abrupt decrease in the thermal conductivity. And similarly for copper we have the thermal conductivity is reduced with increasing temperature, and it remain almost constant from 100 to 1000 degree, from 100 to 1000 K. So this is some variation for thermal conductivity with increasing temperature for different solids, fluids, and gases and liquid material. The other part of this lecture is devoted to the understanding of convection process. Along with the heat conduction and radiation, convection is also a process by which heat can be transferred from one place to another place. But in case of heat conduction, the heat is only transferred by means of thermal vibrations, or by means of thermal vibration. The atoms just transfer the heat without migrating from one place to another place. In heat convection, the process is a bit different, and in that case, the liquid or the gas, or in our simple case we say the fluid, when it is heated, then this fluid by itself can move from one place to another place, taking the heat with itself and just transferring the heat from one place to another place. So it is actually the flow of liquid or gas absorbing heat at one place and then moving it to some other place, mixing with a cooler portion of that fluid. And this process is called as heat convection, or the process, the current or the heat flow, in this case the water or the fluid or the liquid that is moving, or the gas that is moving from one place to another place due to the gradient or due to some force. So this is actually called as a convection current. So we have two type of convection process. We have two type of convection process. One is the natural convection, and the other is the forced convection. In the case of natural convection, the fluid move from one place to another place due to the difference in density that accomplish the temperature difference. It is the natural process. But in case of forced convection, the fluid is forced to move from one place, forced to move from a place at high temperature towards a place at lower temperature, and that is done with the help of some pump or fan or some other thing. So this is actually called as the forced convection process. So the heat convection, we can calculate the heat convection for some material, and this is a bit complicated process than compared to the heat conduction process. So what we need to do, we consider a fluid in contact with a flat or curved wall having different temperature than the main body of the fluid. So what we do, when a fluid, maybe a gas or maybe a liquid, that is placed in a container, but the surface of that container is curved wall or maybe flat depending on the nature, but keep in mind both ends of that wall are at different temperature, or maybe on one side we use a heat source, maybe a flame or some other thing to increase the temperature. So what happened? So heat is transferred, in this case both by with the help of conduction or convection process, because the container in which the fluid the gas or the liquid is placed, that is definitely a conductor. If it is insulator, heat will not flow throughout it. So definitely that is a conductor. So the flame or the heat source that is transferring the heat that fall on that conductor, and that part of the liquid that is in contact with the conductor body, or with the flat or curved part of the that particular a utensil or an object in which it is placed, that is contact with it. So as a result of that, it is heated. When it is heated, it move up or maybe to different place, and the cooler layer, the liquid that is at low temperature come to this place and replace it, and again it is heated with the help of the conduction. So this is actually the combination of conduction and convection process leading to the transfer of heat from the heat source towards the in that particular object. So the heat flow in this case is equal to HA del T. That is also depends upon the difference of temperature. So we can have this value for heat flow. So here A is the area of the wall, del T is the temperature difference, and H is the convection coefficient. So heat convection depends on various parameters, and it depends upon the nature of the walls. It may be flat or curved. As I told you, the container in which you place the fluid, it may be liquid or gas, that is also a matter. That also depends. We also need to take into account the quality of that material, whether it have low conductivity, high conductivity, because it play a very important role. It is actually the barrier in between the heat source and the fluid, what we are increasing its temperature or changing its temperature. So it depends upon the nature of the wall. It depends upon the orientation of the wall, how the wall is oriented. This is also important for the orientation of the wall, whether it is horizontal or vertical. It also depends upon the fluid that is in contact with the wall, is gas or liquid. We have different fluid or convection coefficient for gas and for liquid. We have different value for that. And it also depends upon the density, viscosity, specific heat, and thermal conductivity of that fluid. We have different parameter, and that depends upon the property of the fluid as well. Actually, density, viscosity, specific heat, and thermal conductivity are the properties of that particular fluid. We need to know the speed of fluid as well. If there is huge difference, so that will have difference. There will be laminar flow of heat, and if there is a large difference, so there will be turbulent flow of heat. So it also depends upon the evaporation, condensation, formation of scale takes place. So this is some factor on which the thermal conductivity of the material depends, on which the heat convection process depends. So in this lecture we actually discussed the conduction and thermal conductivity and heat convection. In the upcoming lecture we will discuss the radiation and the different laws to describe the radiation process. Thank you very much.